Hello friends, today's question. A particle of unit mass is moving along the x-axis under the influence of force and its total energy is conserved. Four possible forms of potential energy of a particle are given in column 1. A and U0 are constants. Match the potential energy of column 1 to the corresponding statement of column 2. So this is column 1, which have four types of potential energy, and these are the various 5 options with which we are going to match them. So first of all, it is given that the total energy is conserved. So from here we can draw one conclusion rather, that for conservative force F is equal to minus du by dx, where A is the representation of the energy and x is with respect to the displacement. So let us take all the cases one by one and try to solve it. So for case A, we are given that u1x is equal to u0 divided by 2, 1 minus xa whole square and whole raised power 2. So let us find out first of all the value of the force. So in this case we are going to call force as F1. So we can say our F1 will be equal to minus du1x by dx, which we can derivate, and this will be coming as, this will be minus 2u0 divided by 2, and this will be our 1 minus x whole square multiplied by, we get this as 0 minus 2x upon a square. So here 2 cancel out with 2, and we can say that F1 is equal to minus u0, and this we can take a square here and a square here as common. This will be coming as a4, and here we can write a square minus x square multiplied by 2x, or we can say that our F1 is equal to minus 2 u0 divided by a4. This will be our x, and if you multiply by x, this will be x square minus a square, and we can write this as x square minus a square. This can be further simplified as, we can say that our F1 will be coming as minus 2 u0 divided by a4. This we can write as x minus a as well as x plus a, and multiply by x. So if we see all the options, we can clearly see that it is trying to find out the force will be 0 at various value of x. So from this equation you can say F1 will be 0 at x is equal to 0, x is equal to a, and x is equal to minus a. So from here we can say that the correct option, initial correct option rather, you can say a will be equal to p, q and r. all these three options can be written with the help of this particular solution, that the force acting particle is 0 at x equal to a, x is equal to 0 and x equal to minus a. So this is true from this particular solution. So this is our partial solution for A. Now we are going to check it for the next two solutions. In the first part, it says that the particle experiences an attractive force towards x equals 0 in the region modulus of x is less than a. So let us try to solve the equation. So in order for the attractive force, you can say for attractive force, F should be directly proportional to minus of x. So let us find out whether this equation or this relationship is true when in the region modulus of x is less than a. So we can say for modulus of x is less than a, which basically means that x is going to lie between a and minus a. So under this condition, you can say that now the variable x is available, which is dependent on x a, is x minus a and x plus a. So from here we can say that our x minus a and x plus a will have opposite signs. For modulus of x is less than a, which basically means that if x minus a is positive, then x minus a will be equal to negative, or we can say if x minus a is negative, then this is plus. If x minus a is negative, then x plus a will be equal to positive. And these two conditions are based on modulus of x is less than a. So as their sign is opposite, there we can say that product of x minus a as well as x plus a will be always negative. Now second part, you can say, let us call this as equation number 1. So from equation 1, you can clearly see that one negative sign is already present. You can say from equation 1, f1 is equal to negative, and we are going to get one negative from here, so their product will be equal to positive. So as their product is positive, this relationship as f1 is having positive sign, the relationship f is directly proportional to minus of x does not hold for modulus of x is less than equal to a. So if it doesn't hold, so it means S cannot be the correct option for A. Therefore we can say thus A cannot have S as its correct option, or we can say A cannot be S. Now we are going to find out the third option, that is T, that particle has a total energy E naught upon 4, or rather U naught upon 4, and it is oscillate about point x is equal to minus of A. So we are going to find out that what will be the value of energy at x equal to A. Therefore, what we do, we take the second derivative and taking second derivative, we can say that du upon dx square will be equal to 2u naught divided by a raised to power 4, and we get 1 x minus a, x plus a, and this will be plus, and we get x into x minus a plus x into x plus a. Now we find out the value of the second derivative at x equal to minus a. So we get 2u naught upon a4, we get minus a plus a plus minus a and plus minus a into minus a and plus a. So this term and this term comes 0. So we get this double derivative will be equal to 2u naught divided by a4, and this will be equal to minus of a multiplied by minus of 2a, which will be equal to plus, this will be 4u naught a square. We are more or less interested in the sign. From here we can say this is equal to positive. Therefore, du d naught upon x square at x equal to minus a is greater than 0. So if it is greater than 0, we can draw one conclusion that this will be a point of minima. This is the point of minima, and therefore it will oscillate at this point. And let us find out the energy. So we can say that our energy at x equal to minus of a, which we can say like PE1, this will be equal to u naught divided by 2, and we get minus of minus a upon a whole square and whole square, and this will be coming as 0, and we can find out energy at x is equal to 0. We call it a PE2, and if we substitute 0 we get U1 minus, and this will be equal to 0 divided by A whole square, and this equal to U0 divided by 2. Now in the question it is given that the total energy is U0 upon 4. So if you make the comparison, from here we can say its potential energy total will be equal to 0 plus U0 upon 2, which equal to U0 upon 2, and this is if you make comparison between U0 upon 4 and U0 upon 2, we can say U0 upon 4 is less than U0 upon 2. From here we can say that particle is going to oscillate about, particle will oscillate about x equal to minus of a. So we can say that T is also one of the option for A. So it means A is going to have options as P, Q, R and T. So we can write it here. Therefore A will have the option of P, Q, R and T. Similarly, we can solve for part B also. It is given that U2x is equal to U0 upon 2 x upon A whole square, and once again let us suppose that force is F2, which will be derivative of U2x upon dx, and we can say, sorry, with minus, this will be coming as minus U0 upon 2, this will be equal to 2x upon A, and multiply by 1 upon A, which will equal to 2 cancel out with 2. We get that F2 is equal to minus U0 upon A square to x. And once again we are going to find out the value of F2 at various values of x when it will be 0 basically. So from here making comparison, we can say F2 is equal to 0 only at x is equal to 0. It means only option Q is true for B. From here we can say that B is having right now Q correct options. Okay, among at least first 3. P cannot be because there is no with respect to A. There is only one variable, that is x. Next we are going to find out the test rather the part S, that is attractive force. We already know that for attractive force F2 should be directly proportional to minus of x for modulus of x is less than A, which basically means that x should be lying between minus A and plus A. Now if we make analysis of this equation that states that F2 is directly proportional to minus of x. It basically means that force is directed in opposite direction to the direction of displacement, So basically means that if x is positive, so under this condition the F should be negative, okay, which also means attractive. And if x is negative, then F should be equal to positive, which also means attractive. Now we want to check for modulus of x. So we can say for modulus of x less than a, from here we can say that regardless of sign of x, the force will be always directed towards the origin. Okay. So origin means at x equal to 0. So it means B is going to have S as one of its correct options. Now let's check it for last part. Once again we are going to find out its double derivative. So we already know that our, here it is, one second, yeah, F2 is equal to minus u0 upon 2 multiplied by x. So we find out about x is equal to minus of a. You can say at x is equal to minus of a, we get F2 will be coming as positive. So therefore no oscillation possible. And this can be done in the different like in the part first also. If we double derivative it, you can see that the energy will be coming as independent of, let me double derivative, we can see from here also, this will be coming as u0 upon 2. Okay. So it means it is basically a, you can say, independent of, and if you make the comparison with u0 upon 4, you can say that u0 of 4 is less than u0 upon 2. Yeah. Now we come for the C part. I forgot to mention that B cannot have T at its one of correct options. So therefore B is going to have only two options correct. One is Q, another one is S. So we can say that B is going to have only Q and S. These are the only two correct options. Now let us discuss part C. For part C, U3 x is given as u0 upon 2, and we have x upon a whole square exponential. This is minus x upon a whole square. And once again, we are going to find out the force F. Let us call that F3, which is equal to derivative of u3 x divided by dx, and this derivative will be coming as u0 upon 2 we have this as it will be coming as x minus a, x plus a, and e raised to power xa whole square. So once again we can say that F3 will be 0 at x equal to 0, x is equal to a, and x is equal to minus a. So it means for C part, initially we can say P, Q, R are the three correct options. Now let us check whether part S is correct or not. So for, we can say, attractive force, F3 should be directly proportional to minus of x for modulus of x is less than a. So here, if you see the equation, the sign of F3 is mainly determined by this, because this will be a decreasing function. We can say sign of F3 is determined by x minus a, and x plus a as e raised to power minus x upon a whole square will be decreasing as x moves toward 0 and approaches 0 at x equal to 0. So we are going to check the sign of F3 based on only these three. So we can say that F3 for x minus a, and x plus a. We previously discussed that x minus a and x plus a, they will have opposite signs. Therefore, the product x minus a as well as x plus a will be coming as negative. This is coming as negative, so you can say that f3 is directly proportional to minus of x. If this is true, then we can say it is going to have a attractive force. Towards origin, or we can say x equal to 0. So it means for C, S is also one of the correct options. Now let us check the energy part. We find out its double derivative. You can say d upon dx square is equal to minus u naught upon a cube, and we have this is x minus a into x plus a plus x minus a, and this will be plus x plus a, and this will be plus x of x minus a, x plus a, and multiply by e raised to power minus this whole square. So let us find out the value of du x square at x equal to minus of a. We can say that this term will be equal to 0, and we have this term also equal to 0, as well as this term also equal to 0. So this will be minus u naught upon a cube, and we have minus of a, minus a, and minus a, and this is e raised to power minus, this will be minus of a divided by a whole square. So we are only interested in sign. So we get u square double derivative at x equal to minus of a is equal to negative, and which is less than 0. Therefore, it will have maxima at this point, and we can also say no oscillation will be possible. If no oscillation is possible, then option number T is not the correct option. From C, we can say that T is not the correct option. Therefore, for C, it is going to have P, Q, R, and S. So for C, it will be P, Q, R, and S. And let us solve it for the last part, that is D. We are given that u4x is equal to u naught upon 2 x upon a minus 1 by 3 x upon a whole cube. So let us find out the force. We get that F4 is equal to minus du4 upon dx, which we get this is minus u naught upon 2. This will be equal to 1 upon a minus this will be 3 upon 3 multiplied by x square divided by a cube. 3 and 3 cancels out. You can say that our F4 will be equal to, we can write this minus u naught upon 2, this is equal to 1 upon a minus x square a cube. This is minus u0 upon 2. Taking a cube as LCM, we get this a square minus x square. So we can say that our F4 is equal to minus u0 upon 2a cube. We can write this a minus x and a plus x. So from here we can say that our F4 will be 0 at x is equal to a and x is equal to minus a. Therefore, only the two correct options, that is P and R, will be possible. Q option is not correct one. So we can say for D, we have P and R, the correct options. Now let us check the last two, S and T. So once again, we can say for modulus of x is less than a, the product of a minus x as well as a plus x will be negative. If the product is negative, from here we can say that F4 is having a negative multiplied by negative, which will be giving us a positive. Therefore, F4 directly proportional to minus x does not hold or is not true. Therefore, D cannot have S as a correct option. So D cannot have S as a correct option. Now let's check for the last part. Energy, we find out the double derivative. So D double derivative of energy with respect to, we get this as a minus u0 upon 2a cube and we get x plus a plus x minus a. A cancel out. Get this as dx square is equal to minus u0 upon 2a cube multiplied by 2x. 2 and 2 cancel out, so this will be minus u0 upon a cube multiplied by x. We find out its value at x is equal to a. Double derivative x square is equal to minus, at x is equal to minus of a, this will be equal to minus u0 upon a cube minus of a, which will be a positive, greater than 0. If it is greater than 0, so from here we can say that minima exist at this point. Minima exist at this point. We can find out its value, that at x is equal to a, we get u4x is equal to u0 upon 2. This will be equal to a upon a. This will be minus 1 by 3 and we have a upon a whole cube, and a cancel out here, also it cancels out, so we get a 4x is equal to mu naught upon 2, we get 1 minus 1 by 3, and sorry, this is minus, so this will be equal to mu naught upon 2, get minus 3, and this will be minus plus, so this will be plus 1 divided by 3. So we can say that energy will be coming as, this will be minus of 2 mu naught upon 3, 2 and 2 cancels out, so this equal to mu naught upon 3, and this is obviously less than mu naught upon 4. Therefore, oscillation is possible at this point. Oscillation is possible at x is equal to minus of a. Therefore, one of the options D is going to have D as its correct option. Therefore, D is going to have P and R and T as its correct options. So D is going to have P, R and T as its correct options. So this completes the question. Thank you.